So we were discussing about the hardness of water, right? So we have two types of water mainly. Okay, one is called soft water and the second one is called hard water. Soft water, hard water. Soft water means water which we can use for drinking purpose. Okay, so such water is called soft water. And hard water means which we cannot use for drinking purpose because some type of salts are present in it. Okay, such type of salts are called okay, hard water. So what is the difference between these two? Okay, how can we taste, how can we test it? Okay, if the water is given without tasting it, how can we test this whether the water is a soft or hardness? Okay, then what can we do? Here you can see here in this we are taking the two conical flasks. So these are the two conical flasks. For example, you think we are taking 100 ml of water here, 100 ml of water here. For example, you think we are given two types of water. One is hard water, one is soft water. Okay, and we don't know in that which one is a hard water, which one is a salt water. Now we want to test it. So how can you test it? For this, what you have to do? You take 100 ml of water in this one, 100 ml of water in this, okay, conical flask. Now take a pinch, just 1.2 or 2 grams of soap. Okay, so drop in this one and drop in other one also. Okay, so take just 2 pinch of soap, 1 pinch you drop in the first beaker and the flask and second one in the second flask. Okay, now close the open end. Okay, then you shake both the tubes vigorously. Okay, both the flasks, okay, fastly. Then what you will observe when you shake the soap water, you will get the bubbles. Yes or no? Foam is formed. So here you can see the more foam is there. Can you see on the screen here? The foam is more here. Foam means what? Burugu. Okay, nurugu, burugu, what you say, that all. Okay, so here you see till here the foam is there. Yes or no? Okay, but here you see there is no foam, but what happens, the salt is settled at the bottom. Okay, so the water which gives more foam or more lather with the soap is called soft water, and the water which gives less foam, okay, or no, okay, only which form the precipitate with water is called hard water. Is this clear to you now? Okay, soft water and hard water. So once you see groundwater is main source of water used for various purposes. So generally mostly we use a groundwater only, right? Since this water remains in bottom layers of earth crust for a long time, it contains many dissolved salts. So generally what you, the water you take from your bore, okay, in your home, then you will observe that this bore water will be little salty than the water which government is supplied to us, like municipal water, right? And what the water we drink, like bubble water, okay, mineral water, what you say. Okay, so why? Because for a long time this water is in the bottom layers of the earth crust. So in this so many salts are dissolved. Okay, so depending on the type of salts dissolved in this one, the waters are classified into two types: soft water, hard water. Water which freely form lather. Lather means what? Burugu. Okay, what you say? Nurugu. Okay, so nurugu, right, in Telugu. Okay, so which forms more lather with soap, that is called as a soft water. And water does not form lather with the soap and forms a precipitate. Precipitate ante what? Which is insoluble substance, which is, okay, settled at the bottom. Such substance is called as a, okay, precipitate. So which forms precipitate but do not form the lather is called as a hard water. Is this clear to you?
Yes, sir.
Chalo, take the screenshot of this one. I'll move.
Sir.
2. Very good boy. So here what causes this hardness of water? Soft water it's okay, but hard water it contains the salts, dissolved salts. Which dissolved salts, okay, causes this hardness of water? So here the salts present in the water, mostly the bicarbonates of calcium, bicarbonates of magnesium. Similarly chlorides of calcium, chlorides of magnesium, sulfates of calcium and sulfates of magnesium. Total 6 types of salts are there, you see. Okay, so see here, I will write here, okay, bicarbonates, okay, bicarbonates of calcium, okay, and bicarbonates of magnesium. Okay, now similarly, yes, sulfates of calcium and sulfates of magnesium and chlorides of calcium and chlorides of magnesium. Okay, so these are the 6 types of salts. Okay, so what are they? Bicarbonates of calcium, bicarbonates of magnesium, and sulfates of calcium, sulfates of magnesium, chlorides of calcium, chlorides of magnesium. So mostly these are the 6 types of salts dissolved in water, which causes the hardness of water. Okay, so see here, if the sample of water contains calcium and magnesium bicarbonates, chlorides and sulfates, they do not allow the formation of much lather. So your hard water is not forming the much lather. Okay, why? Because here these types of salts are there. Which type of salts? Bicarbonates, chlorides and sulfates of calcium and magnesium. These salts are there. So these salts do not allow the water to form much lather. Okay, so therefore these salts causes the hardness of water. So these salts are responsible for the hardness of water. Is this clear to you?
Yes, sir.
Now again this hard water is classified into 2 types. Again this hard water is classified into 2 types. Okay, one is called temporary hardness of water, second one is called permanent hardness of water. So temporary hardness of water, permanent hardness of water. Temporary hardness of water is caused due to these type of salts. Okay, so this type of salts are caused, that is bicarbonates of calcium and magnesium causes a temporary hardness of water, and these 4 salts, sulfates and chlorides of calcium and magnesium, causes the, okay, permanent hardness of water. Temporary hardness of water can be removed easily. Okay, just by boiling also we can remove, but permanent hardness of water, it will be little difficult to remove the permanent hardness of water. Is this clear to you?
Yes, sir.
Take the screenshot of this one also.
Look, sir.
Right. So see here, temporary versus permanent hardness of water. First see the definition of temporary hardness of water. Temporary hardness of water due to the presence of, see, calcium hydrogen carbonate and magnesium hydrogen carbonate. Here hydrogen carbonate or bicarbonate both are same. Don't think that these both are different. Okay, so bicarbonate or carbonate. So for example, calcium bicarbonate or calcium hydrogen carbonate is formula is this one. Okay, so magnesium bicarbonate or hydrogen carbonate is formula is this one. So you have to remember the formulas also, very important. In the examination we give the formulas also. Okay, so note down that formula, CaHCO3 taken twice, that is called calcium hydrogen carbonate or calcium bicarbonate. Similarly, MgHCO3 taken twice, that's called magnesium bicarbonate or magnesium hydrogen carbonate. So these salts causes the temporary hardness of water. Then what causes the permanent hardness of water? Permanent hardness of water due to sulfates and chlorides of calcium and magnesium. So in the previous slide I written that also, see here. So yeah, bicarbonates of calcium, bicarbonate of magnesium for temporary hardness, sulfates of calcium and magnesium, chlorides of calcium and magnesium causes the permanent hardness of water. This only is there. So sulfates and chlorides of calcium and magnesium. Okay. So causative agent, what is the main source? That is carbonates and bicarbonates. So here sulfates and chlorides, same thing. Now removal through boiling. Can we remove this hardness of water? Means can this hardness of water can you convert into soft water just by boiling? Means temporary hardness of water is yes. So see a hardness of water. Which water? This is temporary. Temporary hardness of water can easily removed by boiling water. Okay. But hardness of water, which hardness? Permanent hardness of water cannot be removed by boiling. Difference you see, very important. Okay. And some other methods what we can use? We can use a softness. I'll explain you, like permutite, zeolite, so there. And here we use ion exchange columns, or we can say resins. Okay, I'll explain that also. So these resins are used to remove the permanent hardness of water. Is this clear to you?
Yes, sir.
Right. So this is about the, okay, very important. So temporary, permanent. Temporary due to calcium and magnesium bicarbonates, here chlorides and sulfates of calcium and magnesium, and this can be removed easily just like by boiling. Here we cannot remove, here we just use the softness, but here we have to use the resins. Take the screenshot of this one also. Okay, so that is about the bicarbonates of calcium and magnesium. Okay, now what is the disadvantage of this hardness of water? If hardness of water is there, if the salts are dissolved in water, then what is the problem to us? What are the disadvantages? So disadvantage, first disadvantage is what? We cannot able to drink this water because this water is salty, because in the salts are present, so we cannot drink this water. Yes or no? Okay, the water is salt, can you drink? No, we can drink only sweet water, means what? Soft water we can drink, so it cannot be used for drinking. And see here, already in the previous slide I explained you that soft water give the more lather with soap and hard water does not give. But when you want to wash the clothes, then the clothes dirt will be removed if the lather is more. Yes or no? Okay, if want to remove the dirt, okay, from the clothes, then we use the soap. Why we use the soap? So because that gives a much lather, so as a much lather it gives, so easily the dirt will be removed. But here what happens? Here the hard water cannot give the much lather, so that's what it cannot be used even for washing the clothes also. Is this clear to you? Next, and hard water is also from the scale. So see here, you can see in this picture here you can see. So hard water makes all the like devices what we are using, metal devices, it forms a scale on this one. See, this is if using the soft water. See, soft water it is smooth and shiny. So but here you see it is like forming the scales just like rust. Okay, a layer is formed. This is called as a scale soft layer, and this okay reduces the conduction of heat and that waste the energy also. Okay, so these are the things. Now let us see here. Due to the presence of various dissolved salts in water, hard water is not suitable here, is not suitable for the use of various purposes, like not suitable for drinking, it cannot be used for drinking. Due to very poor lather formation, it not effective in washing and cleaning and bathing purposes, so it cannot give the much lather to us, so much foam is not giving, so we cannot use. And the scale formation in the boilers results loss of heat and wastage in the industries, and even not effective for dyeing the fabrics. Okay, so dyeing the fabrics means what? Imparting the color to the fabrics is called as a dyeing the fabrics. So this also will not be quality wise. So these are the some of the disadvantages of hardness of water. Clear? Yes, this also take the screenshot. Yes, but are you writing all these things in the notes or not?
Yes, sir.
This is most important. You have to write the notes. Chalo. Now we came to very important topic of this chapter, that is how to remove the hardness of water. Okay, so for example, you think somewhere you are going and you are stuck there and there is no facility of like water which we use soft water, okay, bubble water, mineral water is not there, only you are having hard water, okay, like borewell water. Now if you want to drink that water, but that water is salty because salt are dissolved in it. Now how can we convert this hard water into soft water? Okay, so here in this topic we are going to discuss what are the methods to convert the hard water into soft water. Okay, so first we see how to convert the temporary hardness of water into soft water. Then we see how the permanent hardness of water can be converted into soft water. Clear? Okay, now let's see one by one. So see now, first types of hardness of removal of water. So this is for temporary hardness of water. This methods what I am explaining here, this is to remove temporary hardness of water. Okay, temporary hardness of water, removal of. So I am writing here removal of temporary hardness of water. So the first method is by boiling. Just now I told you that by boiling. So temporary hardness of water can be converted into soft water, means like drinking water, by boiling. Okay, so by boiling what happens? So I said you that temporary hardness of water contains bicarbonates or hydrogen carbonates of calcium and magnesium, and these are very important here. Okay, try to understand here. Here hydrogen carbonates means bicarbonates of calcium and magnesium are soluble in water, means they dissolved in water. Okay, now what we have to do is, on boiling, if we boil the water, on boiling what happens, this bicarbonates of calcium and magnesium are converting into insoluble carbonates. What it converts into, Chaitanya?
Insoluble carbonates.
Insoluble carbonates. So temporary hardness of water contains bicarbonate or hydrogen carbonate which are soluble. They are soluble in water, so they dissolve. Now if we boil, then what happens? If we boil, then this soluble bicarbonates can be converted into insoluble carbonates, means water which are not soluble, okay, in water, and they form the precipitate. What they form? Precipitate. Okay, like insoluble substance they form. Now if you filter them, all insoluble substance will be separated, we get the pure water. Is this clear to you?
Yes, sir.
So see here, very simple. For example, you see, if we have water, okay, this is hardness of water, temporary hardness of water, and this water, okay, this water is temporary hardness of water, and in this okay, what are they? Soluble, means what? Already dissolved. Okay, soluble bicarbonate, CaHCO3 taken twice, or MgHCO3 taken twice. So these are soluble salts are there. Now what I am doing, I am boiling this water. What I am doing? I am boiling this water. Okay, boiling. I am boiling, what happens? This will dissociate. This hydrogen carbonates or okay, bicarbonates, what happens? They dissociates. Dissociates means what? Splits, breaks. Okay, so see here, this hydrogen carbonates are breaking into carbonate. So see here, here you can see hydrogen is there. Here hydrogen is there, but here see there is no hydrogen there. Yes or no? Okay, there is no hydrogen only. So here hydrogen is there, here no hydrogen. So these are called hydrogen carbonate or bicarbonate. These are called carbonates. Okay, and so hydrogen carbonates, what's happening? They are converting, okay, they are converting into carbonates which are insoluble in water. Insoluble means what? They are not soluble. Okay, they are not soluble in water. So what happens now? On boiling, okay, on boiling, they forms insoluble salt here. What it forms here? Insoluble salt. Okay, insoluble carbonates are formed. Now what I do? I will filter now this water. I will filter now. Okay, so I will take one vessel. Okay, like this, and in this I will keep one funnel. Okay, and I will put one filter here. Okay, like this filter I will put here filter. Now I will filter the water. Okay, on filtering what happens? Only pure water I will get here. The pure water I will get. This undissolved salts, okay, will be left there only. So like this, now this water is free from salts. Now this water we can use for drinking. Is this clear to you? Yes, Chaitanya? I hope it's clear. But once again, so see here, on heating, see, temporary hardness of water is due to bicarbonates of calcium and magnesium. So when you heat or when you boil this water, this bicarbonates are converting into carbonates, and which are insoluble. See, arrow mark it's given down means what? They precipitated, means they are insoluble in water. Okay, now insoluble salts are formed here at the bottom of this, okay, vessel. Now after that we filter this water, we cool it, we wait for some time, and then we filter this water. So only pure water comes down, and the salts will be filtrated here. So like this, the salts will be removed and the water get purified. Okay, so that is the boiling. Okay, now let's come to the second method, is by Clark's method. Clark's method is very simple. Okay, here we need not to boil also. Here we have to use Clark's agent. Clark's agent means what? Calcium hydroxide. We take certain amount of water, temporary hardness of water. So we take some temporary hardness of water here. Okay, in this temporary hardness of water, what we add? Calcium hydroxide we add. So in this we are adding some calcium hydroxide and we mix this one. Okay, and we keep aside for some time. So what happens? This calcium hydroxide react with the bicarbonates. Okay, already there are bicarbonates are there in this dissolved water. So they react with the bicarbonates, and again it will be converting into the carbonates only. Again, okay, this is converting into the carbonates, which are, see, again arrow mark is downwards. The meaning is what? These are undissolved. Means what? They form the precipitate. Is this clear to you? This is very simple. Just you are taking a vessel. In that we are taking the temporary hardness of water, which contains bicarbonates of calcium and magnesium. Then in that we are taking some calcium hydroxide and we mix with that water and keep aside for some time. Then what happens? This calcium hydroxide react with bicarbonates of calcium and magnesium, and it converts them into the insoluble, okay, insoluble carbonates. Just like in the first method insoluble carbonates are formed, here also we get insoluble carbonates are formed. Now on filtration, again if we filter this water, that can be, okay, pure water goes down and this insoluble salts will be separated. So now what is the water left over? Means water is filtered, that water is soft water, and that water is useful for drinking purpose. Is this clear to you?
Yes, sir.
So these are the two methods, okay, to remove the temporary hardness of water. Chalo, once take the screenshot, and once you read verse first one time. If you have any doubt, you ask me.
Okay, sir.
Here chemical formulas are very important here. Okay, so this is the formula of calcium bicarbonate, this is the formula of magnesium bicarbonate, and this is a calcium carbonate, this is a magnesium carbonate. This is bicarbonate, this is carbonate, and you know that H2O is water and CO2 is the carbon dioxide. I think this you know. So these formulas are very important. So learn the formulas also. Okay.
Okay, sir.
Once read and take the screenshot.
Okay, sir. Sir.
Done. Any doubt in this one? No doubt, no?
No, sir.
Yes, good boy. Now let's go to the next topic. Now this is the removal of permanent hardness of water. In the previous slide what we studied? Removal of temporary hardness of water. So I said, you know, temporary hardness of water is very easy. Okay. So just by boiling or by adding the calcium hydroxide we can remove. But this is permanent hardness of water. Here we require something special. Okay. So by simply boiling or simple methods we cannot use here. We use some special chemicals we use. Here we are using two methods. Okay. One is called permatite process. One is called permatite process, and the second one is called ion exchange method. Here two methods are there. First one is called permatite process, and the second one is called ion exchange method. Okay. So listen carefully now. Okay. So here before going to the permatite process, first what I said, okay, this permanent hardness of water contains, okay, two types of salts, chlorides and sulfates of calcium and magnesium. Yes or no? So these chlorides and sulfates of calcium and magnesium contains two types of ions called positively charged ions and negatively charged ions. This is most important here, positively charged ions and negatively charged ions. So in this calcium and magnesium are positively charged ions. Chlorides and sulfates are negatively charged ions. This you have to remember, very very important. So see here, once I'll explain you. So here it consists of chlorides and sulfates of calcium and magnesium. These are the salts present in permanent hardness of water. In this, chlorides and sulfides are negatively charged ions. What they are? Negatively charged ions, means minus charge. And calcium and magnesium are positively charged ions. Positively means what? Plus. Positively charged ions. Okay. So plus and minus. This is most important here. Okay. So here also somewhere we get here it is there. Okay. Ca plus 2 means positive. Mg plus 2 means negative. Okay, sorry, positive. So here now let us see here. So in this permanent hardness of water, this method is called permatite process. So here you can see in the diagram also, permatite process of softening of hardness. So here what we do, we take one cylindrical structure. So here you can see one big cylindrical structure. Can you see the diagram here? Cylindrical structure.
Yes, sir.
Now in this we are adding, so in this part we are adding permatite or zeolite. Permatite means what? It's a chemical which is called hydrated sodium aluminum silicate. What it is called? Hydrated sodium aluminum silicate, and its formula is also very big: Na2, Al2, Si2, O8, XH2O. So see, Na2, Na for sodium, Al for aluminum, SiO8 for silicate, and H2O for hydrated. So this is a big salt. Okay, this is a big formula of salt, one chemical. Okay, this chemical is called permatite. So very important, the chemical name of the permatite is hydrated sodium aluminate silicate, sodium aluminum silicate. This is one chemical substance which is called as a permutite. So that permutite, okay, we fill, okay, in this cylindrical vessel. Okay, now the sample of water is allowed to pass through the cylindrical tube filled with permutite. Now you see here, from here we are passing hardness of water. Can you see the arrow mark here? So say hard water. So from the top what we are doing is we are pouring, or we are allowing to pass the, okay, hardness of water, permanent hardness of water. Okay, so now when this water enters into this one, see here, as the water passes through permutite, the calcium and magnesium ions of water replaced by sodium ions. So here you see, here in the permutite, sodium ions are there. Which ions are there? Sodium ions. Okay, now the ions of calcium and magnesium which are present in the hardness of water, hard water, that are replaced by the sodium, means what? Calcium and magnesium ions are moving, and in that place sodium ions are going there. Okay, where remember that sodium ions do not cause us the hardness. Okay, calcium and magnesium causes the hardness. So calcium and magnesium ions are removed and are replaced by the sodium ions, okay. So now see here, so this calcium and magnesium ions of hard water are replaced by the sodium ions. Now see, a very important thing is that sodium ions do not cause any precipitate with the soap and do not hinder the formation of lather. So this sodium ions do not cause any hardness, means what? They do not form any precipitate with the soap, or they do not they allow, okay, so to form a more foam, means more lather. Okay, ఎక్కువ బురుగు వచ్చేటట్టు కూడా హెల్ప్ చేస్తుంది sodium. Is this clear to you? So thus now the water is said to be softened. ఇంకా దాంతో వాటర్ మనకి సాఫ్ట్నెస్ వచ్చేస్తుంది, హార్డ్నెస్ is gone. Okay, so now water became softened. Is this clear to you?
Yes, sir.
So once again see, I'll explain you, listen carefully. Here this method is called the permutite process. Permutite, chemically the name of the permutite is called hydrated sodium aluminum silicate. Okay, what is its formula? Its formula is Na2Al2 Si2O8 XH2O. This is the formula. So this simply it is called as a permutite. Okay, what this permutite will do? This permutite will take the calcium, means absorb the calcium and magnesium ions from the hard water, and in that place it gives the sodium ions. Hardness of water is causing due to what? Due to calcium and magnesium. So this permutite is removing that okay, calcium and magnesium and replacing with the sodium. So the hardness of water is gone. Now water becomes softened. Is this clear to you?
Yes, sir.
Now if this process continues like this, okay, if this process continue like this, means from here we are passing the hardness of water, this permutite it is absorbing the calcium and magnesium and it is giving the sodium ions to that. Then what happens in that permutite? All sodium ions will be replaced. Now no sodium ions will be left in this permutite. Yes or no? It is giving all its sodium ions. So it is contains of sodium. So it is giving the sodium ions to that and taking the calcium and magnesium. If the process going on, then what happens? Whatever the sodium ions present in it, all will be already given. So then now no sodium ions are left in this permutite. Yes or no? Then this permutite is called exhausted. What it is called? Exhausted. Exhausted means what? From that all the sodium ions are removed. Now no sodium ions are left to convert the hardness of water into soft water. Okay, so when there is no, okay, sodium ions, then when all the sodium ions are replaced, then we can say that this permatite is exhausted. So here after some time the entire permatite contains calcium and magnesium in the place of sodium ions. This is called exhausted permatite. Okay, that's called what? Exhausted. Exhausted means what? All the sodium ions are removed from that. అన్ని సోడియం అయాన్స్ అది ఇచ్చేసింది అన్నమాట. ఓకే, ఇచ్చేసి అన్ని కాల్షియం అండ్ మెగ్నీషియం అయాన్స్ తీసేసుకుంది. ఓకే, ఇప్పుడు దాని దగ్గర రీప్లేస్ చేయడానికి సోడియం అండ్ మెగ్నీషియం సోడియం అయాన్స్ లేవు. సో దెన్ వాట్ హ్యాపెన్స్, ఇప్పుడు వాటర్ అగైన్ కెన్ నాట్ బి కన్వర్టెడ్ ఇంటూ సాఫ్ట్ వాటర్. ఎస్ ఆర్ నో, డిడ్ యూ అండర్స్టాండ్? సో సచ్ కేస్ ఈస్ కాల్డ్ exhausted. Means what? All sodium ions are removed or over from that, exhausted. Okay, now what happens? Now again it cannot purify that hard water into soft water. So what we have to do? Now we regenerate the sodium ions in that. What you have to do? We have to regenerate the sodium ions. For that what you have to do is we have to add again 10% of sodium chloride solution. Means what? You take some 100 ml of water, in that add 10 grams of sodium chloride and mix it, and again you pour that solution into this one. So what happens? Again sodium ions will be coming into that permatite. So now it is regenerated. Now it's again useful, okay, to continue this process. So see here now, now this can be regenerated by sending sodium chloride here, by sending sodium chloride solution through exhausted permatite. So here see, from here, so when the total sodium ions are exhausted, okay, then what we do is from here, from other end, we are passing 10% of brine. Brine means nothing but a sodium chloride solution. So this sodium chloride solution regenerate the sodium ions in this one. Again the softness process will be continued. So in this way permanent hardness of water can be converted into soft water by replacing the calcium and magnesium ions with the sodium ions. This is called permatite process. Is this clear, Chaitanya?
Yes, sir.
Very good. So once read this one, because very important this one. So read. If you have any doubt, you ask me. So then otherwise you can take a screenshot. Okay.